Hi, this is Asing. You are now watching Asing Math TV. Today, I would like to share the Levene's test on equal variances for two populations. To conduct this test, we have to make sure that the measured variable must be entered at the same column for both populations. And we need one column for the grouping variable. To define the grouping variable, we can go to variable view. Under values, click on the button. For example, we can label country X as 1 and country Y as 2. We should take note that for independent t-tests, the number of observations for the two populations may not be the same. Let's conduct the test. Go to Analyze, click on Compare Means, and look for Independent Sample t-test. Move the variable of interest to test variables. Move country to grouping variable. Define groups. Label 1, the group 1 as 1. Use the label that we used. Group 2, 2. Click on Continue. Click on Options and check for the confidence interval if needed. Click on Continue and click on OK, and we should obtain the result. If let's say we need more decimal places, double-click the table, select the numbers, right-click, click on Cell Properties, go to Format Value, increase the decimal if needed. Click on OK. Also, do the same thing for the second table. Double-click. We should select the numbers, right-click, Cell Properties, increase the decimal if needed, and click on OK. To have better understanding on the formula of the test statistics for the Levene test, let's consider this worksheet. Firstly, we need to obtain the absolute difference between the measured variable and the mean of the respective group. So which means that we have to first determine the value of this Zij. To obtain Zij, according to the description, we need absolute difference. So absolute value between the measured variable. So the measured value, we minus the mean of the respective group. So since this is group 1, so we need to find mean. Mean is the average in other words. And we obtain the mean for this group only. When we check that we already reached the end of the group, we should stop here. Remember to fix the range for this average, since for this group, regardless is this value or this value or this value, they should have exactly the same average since they belongs to the same group. Close bracket and close bracket. Press enter and we should obtain the value. So move the cursor to the right corner until we see plus sign. Click and drag until the end of the group. Stop. Do the same thing for the second group. So it's equal to the absolute value minus the average, since what we need here is the mean. For group 2, select. Remember to fix. So we can press the function key F4. Make sure we have $sign in front of B, $sign in front of the row, $sign. Close bracket, close bracket. Press enter and we should obtain the value. Also, click and drag for all the individual values. Next, what we need here is to obtain the mean for each group. So this is first group is equal to average first group. Select the value until the last one. Press enter. And the mean for the second group equal to average as well, and we need the second group. Select and enter. Next is to obtain the mean of all the Z values. So it's equal to average. Select all the values, all the Z values. Next, according to the formula, the numerator we need Ni. So Ni we have two n's here. First n is 20, which means that in the first group we have 20 observations, and in the second groups or the second samples we have 19 of them. So we need 20 times the average of the first group minus the average of the all values. to the power of 2. Repeat the same thing for the second group. So what we need here is equal to 19, since we have 19 observations only for the second group, times the average of the second group minus the average of all the values, also to the power of 2. Press enter. N minus k, the numerator, n is the total observations, total cases. Since n1 we have 20, n2 we have 19, so total we have 39. Minus k, we have altogether 2 groups here. So which means that it's equal to 39 minus 2, which is equal to 37. For the denominator, we have k minus 1. So 2 groups minus 1 is equal to 1. And the last term that we are going to determine is the square difference between the individual z and the respective mean of the z value. So which means that we need to determine is equal to the individual minus the respective mean of z value for the group. Remember to fix this cell, since as long as first group, we should refer to the same cell and square according to the formula. So click and drag for the same group for the second group. So repeat the same procedure. Individual minus, this time we should refer to the second group. Here, remember to fix the value, and we need to power 2. Also drag, and lastly we should total up, since our intention is to total up the value here. So it's equal to the sum of all these square differences. Apply the formula and we should obtain the W value, which is the test 36. And this is equal to, for the numerator we have m minus k with times the total of this. So we need to times the sum of these two, and we divide k minus 1 times the total of this. Remember to put bracket. Bracket is very important. Numerator 1 bracket, denominator 1 bracket. Press enter and we should obtain the test statistic. As you can see, regardless is by using manual calculation or by using SPS, we should obtain exactly the same value. And now let's interpret the result. So according to what we have here, the hypothesis testing should equal variances versus not equal variances at alpha equal to 0.05. To obtain the critical value, we can make use of SPSS. Since we have SPSS here, so we make use of new book. Make sure the data view is not empty, otherwise we are not able to compute the value. Go to transform, click on compute variable. What we need here, the target variable, simply type any letter. For example, F, since this is the F distribution, and we need the inverse distribution. Look for the F distribution up. You have to bear in mind that SPS always use less than cumulative. So if let's say we type 0.05, then this will be the left tail. What we need is the right tail. So we should take the complement, which is 0.95. We shouldn't take alpha over 2, although this is not equal, because the nature of the test is always right tail. Second question mark is the first degree of freedom. We have k minus 1, which means that it's a group minus 1. So we have 2 group minus 1 is equal to 1. And the number of observations minus number of groups. So altogether we have 39 minus 2 is equal to 37. Click on OK and we should obtain the value. To have more decimal point, go to variable view or simply read from this menu. So we have the value 4.1055 rounded to the nearest 4 decimal places, which means that the rejection region should always greater than the critical value, since the nature of the test will never obtain negative value. And based on the test statistic from what we obtain in the Excel, from the Excel or from SPS itself, we should have value 1.8395. Since the test statistics is less than the critical value, which means that we cannot reject the hash null at 0.05 level of significance. This implies that we can conclude that the populations are having the same variances at 5% level of significance. If you want to conduct the test by using the p-value approach, we should come to the same conclusion as well. As we can see, since the p-value is greater than the significance level, which means that we do not reject hash null as well, and hence we come to the same conclusion. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.